Hello, welcome to this talk, which will focus on technology to enable rural connectivity. How will we overcome the digital divide in future? I am Mohammad Ali Imran. I'm a professor of communication systems and Dean University of Glasgow UESTC. And I also head the communication, sensing and imaging research group at Glasgow. My talk is outlined as below. I will start with the challenge of digital divide and present to you some top-level enabling principles as well as some specific technologies which enable this vision of connecting the unconnected. And then I will show you one great example that I think will really motivate overcoming this digital divide all over the world, which is providing healthcare through digital and connected technologies. And I will present to you some field examples of some recently started or finished projects and give you very brief outline of the future outlook. So the first objective is to break the cycle of poverty. And how we can do that, we have to really enable the new generation of people who are born to some poor families to change their lives by doing more rewarding jobs and more rewarding careers. So 6 billion people do not have high-speed broadband internet. Almost 4 billion do not have any internet access, and nearly 2 billion do not have a mobile phone. So how do we overcome this divide in the opportunities is a key challenging question. And this digital divide not just affects rich versus poor, but it also affects old versus young, able-bodied versus disabled, and rural versus urban as well. So even in advanced countries, many rural areas are not very well covered. For example, in Australia, Canada, or even in United Kingdom, there are rural wilderness where the digital connectivity is very, very poor. And this disables a portion of the population in terms of getting access to digital services and opportunities. How can we fix how the ideas can bridge the gap to overcome this digital divide? We have to bring in the low-cost infrastructure, and we have to provide backhaul connectivity in all those areas. So if you look at the global access problem from an operator's balance sheet point of view, there are pros and cons in terms of the operator providing coverage to rural areas. So of course, the operators who have good coverage in rural areas can claim spotless coverage. They meet regulatory targets much better. They can provide add-on services and other verticals like smart farming, smart agriculture, and smart healthcare. And they also can claim seamless connectivity for their own urban commuters, which are paying them excessive revenues. On the other hand, it's very expensive for them because it gives you much lower net revenue because the cost for per customer provision of coverage is much higher, which results in lower average revenue per user. These rural networks are much more higher maintenance in terms of cost, in terms of effort, because sometimes sending engineers to those remote locations is not only costly, but cumbersome as well. These networks are in many cases energy inefficient because the energy bills could be higher in those areas unless we are using renewable energy sources. So what are the key enabling principles to overcome all this? The first principle is power of good enough. So rather than optimizing the rural networks to an optimum that we expect in urban city centers, we have to just accept the power of good enough for a specific application that is being developed in those rural contexts. Then resource pooling. When everyone is trying to compete to have a network edge or to have a differentiating factor in terms of their service by having their own controlled hardware infrastructure in urban city centers, this desire can be slightly put on one side when trying to cover the rural areas. So many mobile network operators can pool their resources in order to provide a good service in those areas. And then DIY networking. We have to move away from the concept of professionally deployed and professionally maintained networks to include communities and local people to come up with help yourself type of solutions where they deploy DIY networks, which can be then maintained by local schools, local other volunteer and otherwise communities who will come to the rescue of not only deploying but maintaining these networks as well, because it benefits to those communities. And then inclusive architecture to bring the backhaul to all those remote areas. We have to think out of the box and bring in new architectures, like providing high altitude platforms as a backhauling service, using drones to provide those backhaul services, and support many other diverse approaches in order to provide backhaul connectivity. So the second other basic principle is reduction of the cost. And it needless to say that if we can reduce the cost of deploying as well as running the network, the CapEx as well as OpEx, then we can make the positive business case for mobile network operators to start their operation in those areas. And a significant portion of this cost actually can be reduced by providing virtualization of the network, by doing spectrum sharing, by providing a software-defined networking architecture, providing facilities of neutral hosting, forcing mobile network operators to share their hardware resources, and so on. Now coming to some more specific technologies that can be used in order to enable rural networks or rural connectivity, we will focus on 4 of these 5 specific areas. Low cost spectrum, of course, spectrum sharing and use of TV white spaces in an opportunistic manner can enable that. So it's very simple to understand. We will spend a couple of minutes on each of the other 4 technological enablers, starting from the backhauling, what technologies are available and which ones to select. Self-organized networking, which enables lower costs in terms of human resources to operate and maintain the network. User-centric design, which allows us to use the power of good enough. And then finally, the green networking, which helps us in managing the energy bills of the operation of these mobile networks. So starting from the backhauling for rural networks, we have to, as I said, think out of the box and experiment with flying platforms or nomadic mode for providing the backhaul services in a scheduled manner, where mobile networks are created for time duration to provide service. And we have to also explore the role of satellites in providing next generation cellular infrastructure with the challenge of global access to all. And then solutions like high altitude platforms, balloons, providing a much wider coverage areas, but lower latency compared to satellite, should also be considered for rural coverage. Backhauling technologies have to be considered in 2 important aspects: how much bandwidth they provide and what latency they incur. And there are solutions which have low latency as well as very wide bandwidth, like millimeter wave based systems and point-to-point fiber. And ideally, those should be solutions that should be providing backhaul connectivity to everyone in the world. But that's just an idealistic view. Actually, in a practical sense, this is not possible because of many reasons. And that's why other technologies do still have their usage in cellular infrastructure. And the job of a mobile network engineer is to make sure that the right services run on right hardware in order to provide those key performance indicators. So we should not try to force all different services on the very scarce resource of point-to-point fiber and millimeter wave based backhauling connectivity. Self-organized operation will reduce the need of human to be in the loop, and this zero-touch type of operation can be enabled if we have self-configuration, self-optimization, as well as self-healing when a problem occurs. Conventional networks collect data, and we do drive testing to collect that data, and then we have specialized softwares in order to do performance analysis and optimal parameter calculation, and then we need human engineers to reconfigure the network in most of these cases. With the advent of self-organized networking, a lot of data collection can be automated by bringing the mobile handsets into picture, and then we can also take the human out of the loop for performance analysis and optimal parameter calculation, and we can design hardware, for example, antennas and other infrastructure on the base stations, as well as in core network, which can be software programmable. So software-defined networking is one aspect, software-defined or software-controlled antennas and beams is another aspect. And by doing this, we reduce the need of sending engineers onto the poles to reconfigure the network. And this makes the optimization and reconfiguration cycle much, much faster. And that results in a reduced cost of running the network without need of human operators being present in rural remote areas. Finally, energy efficient operation, especially focusing on the base stations which consume significant portion of the energy in running a cellular infrastructure. If we can optimize these base stations, we can reduce the energy bills and the cost of running a network in rural areas can be brought down. In this regard, it's important to explore the power models or energy consumption models of different types of base stations, mathematically model them, use them in simulations to optimize the network as much as we can. And very briefly, some of the ideas of how those networks will be optimized to make them energy efficient is starting from deployment. We have to optimize the deployment of a mix of small and large size cells and relaying technologies. And then we have to devise self-organized management infrastructure in order to in order to control different base stations in different mode of operation. For example, at daytime, when traffic load is high, base stations can reduce their coverage area and serve more users in a smaller area. But at night time, they can expand their coverage and put some of these underutilized base stations in sleep mode to save energy. Similarly, you can switch on and off different legacy radio access technologies like 2G, 3G based on their requirements and needs. And then on a very, very fast time scale of few milliseconds, we have to look at radio resource management in terms of both energy and spectrum. And the objective is to make sure that energy utilization is minimized. You have to be opportunistic in this kind of scheduling techniques. However, you can also notice that all of these, they have some cost to pay, either additional capital costs needed to deploy these new technologies or some latency incurred in terms of wake-up delays. We have to also explore new paradigms like device-to-device communication and having multiple backhauls and switching them on and off as per need in order to reduce the energy consumption of the overall network. Finally, user-specific service provisioning, and the main idea of this user-specific service provisioning is to match the plethora of different services and their key performance indicator requirements to a heterogeneity that has been brought into the network over the time in terms of hardware capability of what can and cannot be done by this hardware. So if we can provide right matching, for example, a service which can tolerate latency should only go on a network which is not especially designed for low latency services, so that that capability and capacity is still available when a new application comes in which requires ultra reliable low latency. We cannot provide extreme ultra reliable low latency service to everyone. So we should not aim for that. We should only aim for a limited number of services to run on a specialized network like this. All other services should be rightly scheduled on the other type of network. Coming to some user-specific service provisioning solutions, the main job is to have an orchestrator which can do end-to-end matching of the requirement of an application with the available hardware resource that can serve that requirement. So how do we do that? We can use some parameters on the application side to advertise its needs, and some parameters on the hardware infrastructure side, including backhaul as well as radio access units, to advertise their end-to-end capability. And then a matching algorithm could be an online machine learning based algorithm can actually provide a good match. And using that matching facility, we can readjust cell expansion offsets in order to force traffic from one type of a cell to another type of cell, which can meet the application requirements in that specific context or scenario. These matching parameters can be learned and then updated over the time using artificial intelligence and machine learning techniques. And what we have shown in our in many of the papers related to this user-centric backhauling provisioning schemes, that the user-centric scheme, although slightly sacrifices the system level throughput. That's why it's quasi-optimal in terms of optimizing the system throughput. But at the same time, with this small cost to pay, it provides an excellent performance in terms of maximizing individual user satisfaction and optimizing the usage of constrained backhaul. This is a system where intelligence is distributed, which is good because you cannot bring down the system just by a failure of one point. And the signaling load is significantly low. It's not intensive in terms of signaling load, and energy consumption is much lower as well. So that is a solution that can actually ensure that we consume just enough energy to provide specialized services on the network. So now I come to another important aspect that really motivates the need to provide global access to digital services or to wireless connectivity all across the globe. And this is healthcare. As you know, that healthcare is fast emerging as a paradigm shift where we will move from the current way of reactive healthcare, where you develop a disease and you go to a doctor, he or she diagnoses and then you recover, to a proactive healthcare where your health vitals are being monitored all the time. And as soon as some problem is predicted or development of a problem is expected, you can be sure of getting help from your healthcare professional to provide you a mechanism of dealing with that problem at much earlier stage. So at Communication, Sensing and Imaging Research Group, we are doing a significant amount of work to address this specific challenge under the Wireless for Healthcare theme. And the main idea of this Wireless for Healthcare theme is to not only monitor people in their homes in order to provide readings of their health vitals, but also ensure that their data is privately and securely collected by the health service provider at a national level or at a local level. And it is ensured that people have full confidence in the privacy and security of their data. Machine learning and other techniques, artificial intelligence techniques, can be exploited in order to suss out useful information out of that big data that will be generated, and that can benefit not only the medical science in terms of development of new therapies, new medicines, but can also provide significant support to individuals, especially when they need care in older age, as well as in specialized care homes. So one important aspect to this kind of healthcare is, first of all, you need good quality connectivity even in rural areas as well, because health is a problem which affects both urban as well as rural areas. The other important aspect is that we should be able to provide connectivity to a very large number of Internet of Things type devices in rural areas as well. And one key aspect of our research at Communication, Sensing and Imaging Research Group is to move away from the need of having to have wearables and other intrusive sensing techniques like cameras to provide seamless monitoring of health vitals without the need of wearables and without the need of privacy invading techniques like cameras. How do we do that? We try to exploit the presence of wireless signals everywhere inside a room or house or a location, and we monitor the channel quality and try to correlate it with different activities that are happening in the room. Learning network learns about the correlation between different channel qualities and different activities, and then can predict with high accuracy the activity happening in the room. And this, combined with very advanced quantum related technologies and time of arrival cameras, can go to the precision of monitoring tremor in people's hands and their breathing patterns, as well as very slight movements in their body, which will be the longer term future of this kind of healthcare technology. All of this requires good level connectivity in both urban as well as rural areas, and that's why it becomes even more important to overcome the digital divide. What are the specific challenges for healthcare data? So one specific challenge is the energy consumption itself. And as I said before, the energy footprint uh, is growing fast because of the need for not only communicating data, but storing data and processing it in the clouds. So that's one aspect that has to be addressed, especially in rural areas. We have to think about how we can reduce the carbon footprint of this cloud infrastructure by bringing the cloud or the edge as close to the rural areas as possible. And for the applications, we require intensive intensive processing, local processing. We can consider a presence of cloud in those areas as well. Data privacy is one of the key obstruction, and it is both for urban as well as rural connectivity. If people are not sure that their data is private and will be kept secure, they would not easily volunteer to share their data, especially their health data, which is very personal, private, and could cause them significant financial losses in terms of their insurances and other aspects. So they would like to be very, very sure that this is private. So blockchain is an enabling and emerging technology which ensures that privacy preservation. COVID-19 as a pandemic has already shown that how important privacy preservation is, to use digital technology to do things like contact tracing, for example. And people will only sign up to a contact tracing application if they are ensured that their data is private and secure. So very briefly, of course, everyone knows how blockchain works. One of the big challenge for the working of the blockchain, which is a distributed ledger technology and requires significant resources to do processing on individual nodes, but also requires reliable connectivity between those nodes to be able to observe and validate the distributed ledger and any entries made to that distributed ledger. So in rural areas, this becomes quite challenging because many of these nodes might not have a reliable connectivity. So overcoming digital divide and ensuring that people have access to privacy preserving techniques in rural areas as well, you have to ensure that they have a good high grade connectivity in those areas. We have developed a new framework which is specifically focused on the provision of blockchain technologies for privacy preservation and contact tracing in light of COVID pandemic. However, the technology has a much longer shelf life because the utility goes beyond just contact tracing, and it will enable sharing of user data securely and privately in future networks. And our focus is how to ensure that this blockchain not only works on connected wired networks, but also works on wireless technologies. And this has recently been published with some other privacy preservation based methods for contact tracing in a Scottish Government DHI report. We are also looking at this challenge of connecting rural areas where many people have a public opinion about radiation hazards. And of course, irrespective of reiterating the fact that there is no scientific evidence that the levels at which we operate wireless communication systems are indeed at safe levels and they don't have any harmful effect on human health. But irrespective of that, there are still techniques by which we can even reduce further the exposure to radio waves for any human by reducing the EMF that is exposed onto them by doing beamforming and targeting the energy in a specific direction, by ensuring base stations are sleeping when they are not in use, and by suggesting very simple precautionary approaches for users to reduce their time of exposure to mobile phones as much as they can. They use it as little as possible, and they use hands-free operation where they can. So all of this really ensures that rural as well as urban population is reassured that these things are already operating under very safe, very safe limits. If you are following all those regulations, then there is no harm to your health. Okay, recent use cases and technology demonstrations. What we have done recently to provide rural connectivity solutions and to overcome the digital divide. Our colleagues in University of Strathclyde led a government-funded project where we partnered with them to provide 5G type of connectivity to Orkney Islands, a very, very remote location in the nation of Scotland. And through this kind of communication infrastructure, a lot of verticals can be enabled, including smart agriculture, smart entertainment or digital entertainment in rural areas, smart farming, better facilities for schools and healthcare centers, and so on. So all of this now, as we move forward, will be experimented with another urban-centered testbed that is being deployed with the help of the Scotland 5G Centre. This project of connecting Orkney Island was funded by Department of Culture, Media and Sports of UK government. We are also responding to the COVID-19 pandemic by looking at how we can deploy mobile units in order to provide testing as well as future healthcare facilities to all people in care homes at their own doorsteps. And for this, you have to provide connectivity to these mobile vans, even when they are in remote rural locations. For example, in the nation of Scotland, in Highlands and Islands, the digital connectivity is far worse than many urban city centers. And to provide good service there, we have partnered with Telefonica O2, specifically their Darwin Innovation Group, and with other local bodies, including Scottish Care, Pacific Care, and our health service, in order to explore how feasible it is to deploy a mobile testing unit and in future mobile health clinic. And this project is also supported by the Scotland 5G Centre's ambitions. So the basic idea is to create a mobile health clinic van, which can be developed and deployed as a proof of concept to provide connected mobile health clinic, which is in a live manner feeding the test results onto a cloud-based solution, which is interfaced with a health service based cloud facility. And then data analytics can also provide you live updates about for example, in this case, COVID pandemic, but in future about other diseases, how we are combating them. So very briefly, some futuristic areas that will also help in good connectivity in urban as well as rural areas. Specifically, I mentioned the application of RF and wireless technologies to monitor people at their homes. So providing a good coverage in rural areas also enables a better home monitoring or care home monitoring facilities within those homes. We are also working on generating smart walls or intelligent reflective surfaces, which will be able to control wireless energy in a much better manner in order to reduce the energy consumption of wireless communication, as well as providing better security and privacy of wireless signals, both in urban as well as rural areas. So some pointers for relevant work that I have just presented. Will 5G see its blind side is one of our pioneering paper, which raised the awareness of overcoming digital divide and providing good wireless connectivity in remote and rural areas as well. We have also worked on feasibility architecture and cost consideration of using TV white space for rural internet access, focusing on 5G. Now we are moving to a 6th generation of communication infrastructure, and some of these considerations have to be revisited. We have also demonstrated to the First Minister of the Scotland how digital healthcare as well as other use cases of 5G can transform the way how we do things as a nation. And there are some titles which specifically addresses some of the things that I presented today, with a special focus on engineering and technology for healthcare. And as I said, to enable this, we have to provide good and uniform service both in urban and rural centers. With this, I thank you everyone for your attentive listening, and I have put my email down here if you have any questions or any requests for collaboration, I would more than welcome any approach by you via this email. Thank you very much.